For this video, we are looking at integration by parts, and it starts with the product rule. So I'm actually going to take a derivative. I'm taking the derivative with respect to x of the product of two functions u and v. So to start with, I take my first function u, and I'm going to multiply that by the derivative of the second, but I'm going to write it as dv dx, because I'm taking the derivative with respect to x, plus the second function v times the derivative of the first, which will be du dx. Now let's just say that we started with something like this and I wanted to work backwards. Then I'm going to integrate all of this with respect to x. Well, if I do the integral of the derivative with respect to x, I'm left with uv. On the right hand side, I'm taking the integral of u times dv dx with respect to x, plus the integral of v times du dx with respect to x. Now remember that when you integrate, you can integrate term by term, so splitting it up like this is just fine. If you look at this, you can see that I have a dx and a dx here and here. So I could say that uv equals the integral of u dv plus the integral of v du. Now that may not seem really earth-shattering, but what I'm going to do here is actually solve for this. So I'm going to say the integral of u dv equals uv, and I'm going to subtract the integral of v du. So I have, if I start with an integral of two things that are multiplied. Now it's important to note that you have to be able to take the derivative of u, because you'll notice the answer over here has a du in it, and I have to be able to integrate dv. There's a v in it twice. So what we're going to do is we're going to look at this and we're going to start here. Because the question becomes, is this integration by parts when you see a function? And what you always try first, what I always try first is u sub. If u sub works, I'm not going to do integration by parts. Integration by parts is the next thing I'll check. Do I have two different kinds of functions multiplied? So does it look like I'm doing the product rule but with an integral? And if so, is u something I can take a derivative of, dv something I can integrate? Because if I can rewrite it in this form. Now that's only going to be helpful to you if you can actually integrate this. Because what you're doing is starting with something that didn't work with u sub or didn't work in some way. Okay, now you've pulled a uv out, so you don't have to integrate that, but you still have to be able to integrate this function right here. So if that doesn't work, it's not integration by parts, or you've made strides, but you're not quite there yet. So this is just something to try. So when you're given a problem, the first thing you're going to try to figure out is, what is your u? What is your dv? And you're going to try it. If it doesn't work, then you might try something else. I spent many weeks in a class not knowing how to pick the u, not knowing how to pick the dv, and it was trial and error, and there's nothing wrong with that. The general rule for me is that if you have a polynomial, you're going to try to make that your u, unless there's a natural log in the function. If there's a natural log in the function, I'm probably going to choose that as my u. And the dv will be the other part of the function. So we're going to look at that with a couple of examples in the next video.